Hope you had a good weekend. We're going to start Unit 11 today. We are going to spend a little while more on arrays. We started working with arrays last week, and we're going to do some more complicated things with arrays this week. And then next week, Unit 12, we're going to work with something called an array list, which is kind of a different, I guess, a more modern version of arrays. These traditional arrays we're using now have been around for a long time, and they have some limitations in that it's hard to add items. You have to have a fixed size of them when you start the array. And that's not always, you don't always know the size of your array when you create it. For example, if you're a company and you have a products that you sell, maybe you have 50 products you sell, you can create an array of 50 products there. But later on, you want to add another, 5 more products you want to sell. That makes it complicated. So again, we'll look at array lists in Unit 12 next week, which allow us to do some stuff with arrays, more modern day stuff like make the array bigger or smaller and stuff like that. But in Unit 11 here, we're still dealing with normal arrays, just a little more stuff with them. One thing I want to go over right away is another type of loop here. There's a common loop. Let me just bring up this example, I guess, that we use with arrays. And that is when we're doing anything with arrays, we often do this loop for like index equals 0, index less than or equal to the array length. And again, sometimes you're putting in a number there, but again, to make it more generic, we usually just say the array length there and index plus plus here. We sometimes will use, rather than saying index, we'll use some other counter. And again, often we just abbreviate it to like I, for I equals 0, I less than equal to array length plus plus, or I plus plus there. And then to get to every component in our array, we'd say array and then sub, put in our square brackets. And then for the index or the counter into the array, we'd use our variable in our loop. So this loop would loop through and print, like this one prints out every other array. You do the same thing if you want to like add up the elements in an array, if you want to find the largest element in an array. There's lots of places where you do this loop with arrays here. Because of that, we have a special version of this array loop here. That's generally called the for each loop here. So in this, we're always dealing with this array sub-index, and we already always have this index. So we can shorten this whole loop here to just say, like, this is an array of strings here, an array of strings. So we can have a different kind of loop that does basically the same thing. And we can just say for, and we're just going to go through each item in the array for string product in the array. And this will go through and set product equal to array sub 0, and then do the loop, set product to array sub 1, go through the loop, array sub 2, 3, go through until you get to the length of the array. We know the length of the array. We're always going to start the 0th element here, and product is going to be set to each element in the array here. And then we can just print off like the product here. So it's a short and simpler version. There's less error-prone places to make errors with this sort of loop for us. So the textbook, well, the CS Awesome goes over this here. And again, this is usually, even though it's still a for loop in Java, in most languages, it's a for each loop. So in like C++ or C# and Python and stuff, the loop is often a for each and then that. But in Java, it's just for whatever the type is, and then the item, array, and we'll loop through each item in the array. For example, here we have a high score array. Here's our array of integers. And again, to do that loop, we say for, and then since it's array of integers, we say int value colon high score. So that value would first be set to high score sub 0, and we do the loop. Then value is set to high score sub 1, and we do the loop. 2, 3, we go through, value is set repeatedly to, so the first time through, value will be 10. The next time through, value will be 9, and then it'll be 8, and it'll be 8 here. And then we can just like here, we're just printing off value. And again, it works similarly for strings. Here's our string of names here. The only difference is, again, if we say for, and then it's string, and then whatever we want the variable called and whatever the name of the array called. So this is the name of each item in the array as we go through it. And this is the name of the entire array for this. So our array is called names. So we say for each name in names, we're going to do system.out print that name stuff. So it's a common new loop we'll use. A lot of companies now, would actually require you to use this loop when possible rather than the other for loop with an index. Because again, you just look at it, it's a lot simpler. You don't have to specify, like here, you don't have to specify the index, and I'll let some people goof up, is it index 0 or index 1? Is this less than or equal to or less than the array length here? So this just simplifies that. So. And then there's some good examples in CS Awesome where they do that. So here's their example of the following code. We can run this. And again, it's printing off each item in the array, each name in the list of names for this. Do it. So yeah, and they're wanting us. So again, regardless of the size of the array, how many items are in the array here, this will still work. Because nowhere in this do we set the size of the array other than the array size. These loops will work through that. So, now, where this doesn't necessarily work is like when we're trying to do every other item. So here they're trying to do this and print off. Well, actually here they're just trying to print off check if a number in the array is even or not, and then print that out. So, but again, if we are trying to print off like every other item in the list, that the for each loop will not work for something like that. Where we're not doing some simple, where we're not looping through every item in the list. I'm not going to do this, but 6.8 has a bunch of good practice things with arrays. And I really think the more you practice the arrays, the better. So like here, fix the following code so it prints every other item value in the array starting with 0 here. And if we run it, it gives you an error for this. And so your job is to fix these errors with this and run this again here. So again, and there's a bunch of review activities here that you can do. So I suggest you look through those at some point. We're not going to do those today because I have another activity for you to work on in just a sec. Two other things we often do with arrays is searching through them and sorting them. So let's just talk briefly about that. Um, we used to teach algorithms for searching and sorting, and we really don't do that much anymore because, well, especially sorting, because there are really good sorting algorithms out there that are quite complicated. And the ones that you generally, that students or people, developers usually write are slow and simple and don't work as well. So, and we cover the same thing in CS principles as we do here, kind of. So we talk about a linear search or sequential search or binary search through things. So if we want to search through elements, if we have an array, we just want to find each element in the or find a certain number in the array. So if we have an array of integers and we have some target, we're going to find search in the array. If they're not in order, we just have to go through the whole array and do it. So again, here we're going for int j equals 0, j less than the length of the array, j plus plus. And so we're going to look at each element in the array. We have this target we're trying to find, so we're just going to search if elements sub j equals the target. So if the number we're searching for is at that location in the array, then we're going to return that. And this return will stop our for loop because we're in a method here. So then, and it's going to say we found it at index whatever for this. So if our array is 3, -2, 9, 38, -23, and we search here, so like here we're doing sequential search and we're searching for 9 in the array here. We will first check if the 0th element is 9 and it's not. Then we'll check if the -2 is 9, it's not. Then we'll check if the the 9 is 9, and it is here. So it'll find it in that location. If we run this, it'll tell us that we found the 9 in the second location. Again, 0, 1, 2, index 2 is where we found this array. So the sequential search, and again, if your elements aren't in order, this is easy to do, and you can just write this often yourself there. But often with bigger arrays, we're going to want to sort them and do a binary search through this. So the binary search, and again, you've probably CS principles. You're either doing it right now, probably, or you did it whenever you did CS principles last year. The question is, how fast can you search through things? And if things are in order, you can search through them a lot faster because you don't have to go one by one through the whole list. Basically, and you've done this before, with pick a number between 1 and 100. If you ask someone to pick and I'll tell you if it's higher or lower, and we can do that with an ordered array there. So if you do that, you're not going to say 1. Is it 1? No. Is it 2? No. Is it 3? No. Is it 4? You're going to say, is it like 50? And then they'll go, oh, it's higher. And then you go, oh, is that 75? And they'll say it's lower. So that's what this does, is that we assume our array is sorted. We're finding our target. And again, we're checking for a left and a right boundary. So at some point, like, oh, I know it's between 50 and 75 there. So the left boundary will be 50 and the right boundary would be 75. And then we divide those in half and check if we should shift things to the, if we get told higher or lower or not. So again, the whole algorithm isn't that big here. And sometimes you write this, but usually most systems will have this built in, will have a search or a find method built into them with arrays that we can use this. So again, we're not going to do this, but again, remember, binary search is so much faster than a linear search for things. So a lot of times it's worth sorting your array if you're going to do lots of searching through it. And again, sorting is that process of sorting. And we, in CS Principles, we usually do a card game or something like that where you're sorting through things and you're trying to learn the selection sort, or what is called often called the bubble sort here, where you're just finding the highest number first here. You go through the whole list, find the highest number, and leave that out. And then you go through the whole list again and find the second highest number and the third highest number, etc. For this. But it takes a long time, and there are much faster sorts here. So there's some good information about sorting here if you're not familiar with sorting here. We just run this example. So here's some of the sorts here. And the more advanced ones are further to the right here. And so if I run this here, you'll see the ones on the right go a lot faster. It's kind of, they do some weird patterns of how they work, but they work very quickly. The merge sort, the heap sort, these things work very fast here. So these 4 or 5 sorts to the right all are very quick. But like these selection sorts, bubble sorts, they're still going. They haven't actually sorted that many things yet in our list for this. And so again, some of them will get a little faster depending on if everything's sorted or not. But again, some of these are still going on for this. So again, if you're sorting something, you should remember that you should use generally the built-in sort commands because they're going to be so much faster. We don't even teach you generally how to sort things because you should be using like a quick sort or something like that generally. And that's what's built into most computers. That's available on most computer systems here. That's one thing, reason why we often use array lists rather than arrays, because again, it's a little, things like the modern array list has some sorting abilities and searching abilities built into them. So that's one of the main reasons why when you, once you kind of learn how to use arrays, you tend to then move to array lists and just use those all the time. Let's talk about one more thing, and then that's two-dimensional arrays here. So far, our arrays have just been a list of items here, kind of like this, a list of items. And we call this just a one-dimensional array or just an array. But sometimes we want things stored more like in a chart or a table here, where we talk about what row and what column this is. And so we see this a lot. You might talk about, people in classes, or you might talk about information, all the students' names in each class or something like that. And you have a whole array, two-dimensional or table of this information then. So we can declare an array like this. Here we say int, and we have bracket, a double set of brackets, give it some name, and we say new int, and then we specify both the X and the Y, or the row and the columns you can think of here. And then we can loop through that. And again, we're often doing loops. So like here, we say int row and column, and then for row equals 0, row less than 5 here. And for column equals 0, column less than 7, plus. And then we're printing off this array, and this will print off that entire array for us. So again, we can have these. Now, you can visualize these as two-dimensional arrays, like a table. Technically, they're an array of arrays here. So here we're thinking it's an array of rows, and each row is a separate array of 7 numbers there. So it's technically an array of arrays. But again, what that basically builds is a table for us. We'll look at some examples of these lab scores here. I don't know if I'll have time today to get to these. This will probably be something we'll talk a little bit on Wednesday about. Um, I'm going to talk just briefly about these examples here. We are just talking about this a second ago, this product example. I'm going to paste this in. Excuse me. Okay, let's grab this. One thing we haven't talked too much about is passing arrays as parameters to methods. And so here are two methods for printing out an array. Public static void print array 1, public static void print array 2. And they both take a parameter, a string array. So that's how we declare it, a string, and then this is an array. And we give it some name. In this case, we're using the creative name of array for our array name. And again, we're printing this out, and we kind of looked at this. All we're doing is doing a for loop and printing out each element in the array, or doing a for each and then printing out each element in the array. Now, when we want to use this, we declare our array. Here's our array of products. And then we say print array, and we pass in that array. So we call print array 1 or print array 2. They're both called the same way, and they print off the items. So when we run this, it simply prints out the items in the array. So here's our first printout. Here's our second printout. And again, we talked about searching here. We can search. So let's say we want to search for the keyboard in our products list here. So we're calling this search method. We're looping through each element in the array. We're checking, and again, this is string, so we have to check with a dot equal. So we check if array sub I dot equals target. Again, this maybe we'd want to ignore case, so we could say dot equals ignore case here. So we're just checking if the target is equal to each array element. We find it, we return it, otherwise return one, a -1. And we call this linear search. We search for the keyboard. And then we might want to check if our index is -1, we say it's not found. Otherwise, we say it was found in whatever index we found it at. And again, so this method is called similarly, but again, since this is a non-void method, it's a public static int, it's returning an index. We want to, when we call that, we want to save that index up here. And then we're passing in our array of products and our product we're searching for. Now here, let's look at one more example of this. And this is a cost, an array of integers. So we have an array of integers of product costs in each of this. And again, we can print that array. And again, that's going to be a void method. So we call it on a line by itself. Just print off that array. Often with arrays of numbers, you should be able to find the largest and the smallest. Those are common methods. How do we do that here? Again, find largest. Here we just pass in our array, and now we're going to return the largest item in the array. So we're going to set largest. We're going to keep track of the largest we've found so far, and we're going to set it equal to the first element in the array, the 0th element in the array. And then we're going to loop through the array. Each time we're going to check if the array value we're checking is greater than the largest we've found so far. If it is, if we found a new larger value, we're going to save that value in our largest variable here. And we're going to keep looping through, and then we return the largest when we're done. Again, find smallest does something similar, except now we're checking if each item in the array is smaller than the smallest we've found so far, and then eventually we return the smallest. Calculate total, how to sum up the values in an array. We pass an array, we declare a total and set it equal to 0. And then we go through our array. And again, here we're using a for each loop for each cost in the array. We're adding the cost of that product to our total and returning our total. So these kind of examples you see a lot with arrays. Again, we haven't seen them necessarily in a method, but this sort of idea of adding up all the elements in the array, finding the smallest element and the largest element in the array, those are common tasks that you do a lot with arrays. And then again, so we've just stuck them in methods. And then in here, we call, we say find largest, we pass it in the list of products, and we store the result as the largest cost. And here's our total, and then we just print those out. Now, I didn't do average because often if you know how to find the total, the average is just the total divided by the length of the array. So you may not actually even put that in its own method because it's just one line. Any questions on these? So we're going to break into little groups here. And we're going to have you work through this searching example with zip codes. So this under Unit 11, the learning material. For the last half an hour class, we're just going to have you go through and do this search example. So I'm going to break you into groups. By color picture. Okay, everyone got one? Okay, okay. Find your color. You should have 2 or 3 people on your team. Get to a computer and you can work on this project. Okay. We're here. So for this project, you're going to want to run some code. You're going to download the GitHub or the zip project and run it. You've got to do the download this or clone it because it has all the zip codes for the United States in it. So again, you can go in here, grab this URL, go to team, git clone, paste it in there, and clone it. So someone should be at a computer then and writing or running this code. And remember, this is just a learning activity. You don't have to submit anything. You don't have to actually complete it. It's just for your learning. So feel free to get as far as you can with it. Class numbers groups got to questions or sections 3 and 4. So that's pretty good.